So what if I told you there's a plan to save a sinking airport, not by fighting the ocean, but by, well, working with physics in this absolutely revolutionary way? We're going to dive into one of the boldest engineering ideas I have ever seen.
I mean, it's the kind of question that sounds like it's straight out of a movie, right? You've got this multi-billion-dollar piece of infrastructure, a true modern marvel, and it's just slowly sinking back into the sea. What do you even do about that?
And right there, that is the brilliant, kind of mind-bending solution we're going to break down. Instead of just piling up more rocks and fighting a losing battle, this plan says, hold on, what if we just got rid of the water? Let's see how that's even possible.
Okay, so to really get why the solution is so genius, we first have to understand just how big of a problem we're talking about. This is a story of incredible human ingenuity going head-to-head with the forces of nature.
See, Kansai International Airport, built out in Osaka Bay, is an absolute triumph of engineering. But it was built on reclaimed land, and that ground has been compressing and sinking way faster than anyone originally planned for.
Now, you'd think the obvious fix is to just add more dirt, right? Just pile on more land. But here's the catch. That's literally the worst thing you could do. Every single ton of new material just adds more weight, which squishes the seabed even more and makes it sink faster. You get stuck in this vicious cycle. So if you can't build up, you've got to think completely differently. And this is where the plan gets, well, really, really cool. The basic idea is just so elegant. You don't even try to fix the island itself, no. Instead, you build this massive protective ring all the way around it. A giant seawall that cuts the airport off from the ocean completely.
And when I say massive, I am not kidding. We are talking about a structure with a 5-kilometer radius. This isn't just a wall, you guys. This is a mega structure. It creates an entirely new coastline. So how on earth do you build something like this out in the middle of the ocean? Well, it's an absolutely incredible process, so let's walk through it.
The whole project breaks down into 5 key steps. It starts deep under the sea with the foundation and ends with this really dramatic moment where you create brand new, dry land. Let's take a look at each one.
Okay, so it all starts with a foundation. Giant 20-meter-long piles get driven deep into the seabed, and they have these brilliant cross-shaped wings on the bottom that give them way more stability in that soft ground. You can think of it like a snowshoe, for spreading out weight, but for mud. So once those piles are in place, huge 20-meter-wide sections of arched sheet metal are slotted in between them. And they're deliberately arched, bowing outward toward the sea. This is super clever because it actually uses the immense pressure of the ocean to make the wall stronger, kind of like how an old Roman aqueduct works.
Of course, an arch like that still needs some backup. That's where the reinforcement comes in. More piles are driven in behind the arches, and heavy-duty steel cables connect everything back to the main foundation. This creates this super robust tension system that makes the whole thing incredibly strong and, most importantly, watertight. And here it is. This is the magic trick. After this colossal ring is fully sealed, they just turn on the pumps, and they pump, and they pump, and they keep pumping until that entire vast area inside the ring is completely dry. They literally remove the sea. It's amazing. But wait, there's one last really clever step. You've got all that ocean pressure pushing from the outside, so you need to balance it. What do? You take the earth from the brand new exposed seabed and you pile it up against the inside of the wall. This not only makes the barrier stronger, it also stops the ground from bubbling upwards. You end up with this perfectly balanced system.
So after all of that unbelievable work, what's the end result? Well, it's way more than just a saved airport. It's like the island is completely reborn. So, yeah, the main goal is achieved. The airport isn't sinking anymore. But the side effect is almost more impressive. You've just created this massive amount of totally new, totally usable land all around the original island.
And what do you do with all that new land? This is where it gets really interesting. I mean, sure, you can build new runways and buildings on top. But now, for the first time, you can dig down. Imagine building huge underground rainwater reservoirs, or massive parking garages, or even just simple cellars. All things that are basically impossible on a normal artificial island.
This whole solution, with all its amazing possibilities, is about more than just concrete and steel. It really represents a fundamental shift, a whole new paradigm for how we think about building on the water.
And when you put them side by side, the difference is just crystal clear. The old method was this brute force battle against the sea, just adding more weight and actually making the problem worse. This new idea, it's elegant. It works with the laws of physics to solve the root problem and create a huge net benefit.
You know, it all comes down to this one simple, beautiful phrase from the original German engineering concept, Einfach das Wasser entfernen. Simply remove the water. Behind all of this incredibly complex engineering lies an idea so simple, it's almost poetic.
And that leaves us with this really profound question. If we can do this for an airport, where else could we apply it? Think about coastal cities facing rising sea levels, or entirely new kinds of infrastructure. This isn't just a rescue plan for one airport. It might just be a blueprint for our future. What do you think?